Welcome to the second video on how we simplify limits. We are currently looking at what we call the indeterminate form when we are trying to figure out what a limit is. We plug in the value, try to do direct substitution, and we get 0 over 0. In this video we're going to look at an example for the second sort of thing that might happen, and in this case we need to do something called rationalize the numerator. This is going to be an example that we don't see a ton of, but still just something good for us to maybe be aware of. So this is going to be the example we look at. We're looking at the limit as x approaches 3 of this kind of complicated idea. Probably a good idea is just to have a general sense of what this might look like. So I did go ahead and just graph this before I started, and I believe I'm going all the way to 5 on this side and to -1 right there, which if you look at the function, that's going to be the start of the domain. It doesn't exist beyond or to the left of -1. And then I went up to +1 here and down to -1. And it just does something kind of like this on a graphing calculator. It kind of starts around here and just kind of slowly gets smaller and smaller. But what you see is it does just kind of keep going. The calculator shows that it continues to exist everywhere. We know because of that denominator that at 3 we're going to have an issue. Okay, we won't be able to actually plug in a 3 because of that denominator. And so there's probably going to be something like a hole there. But the idea of a limit does exist. And I suppose one thing I should have done at the very beginning is to say, well, what happens if we plug a 3 into this original function? So if I plug a 3 into the x in the numerator, I get 3 plus 1, which is 4, inside the square root. So square root of 4 is 2, and then I subtract 2 at the end, I get 0. So this thing would actually get me a 0 on top, and then if I plug a 3 in the bottom, I get a 0 there. So it is that indeterminate form. So let's just go ahead and see how we might approach a problem like this. If I just give myself a little bit more room here. One of the first things we're going to do, anytime we see this square root business, remember we always do write this limit idea down. Again, I know it's kind of a pain. But we're going to have that same fraction, so square root of x plus 1 minus 2 over x minus 3. And remember, this is kind of a chunk here as well. We're going to multiply by basically the idea that's in that numerator, but we're going to switch the sign that's in the middle. So by that I mean we're going to multiply here, and I'm going to multiply by the square root of x plus 1. But now I'm going to add 2. And you'll see why in a second, why we do this. But if I do that on the top, and I don't want to change the actual idea of this fraction, I need to multiply by the same thing on the bottom. Okay, so it's kind of like multiplying by 1. So I've set that up. I know it looks a little messy, but it'll simplify here pretty quickly. So I'm going to, again, write down the limit as x approaches 3. I want you to think about what's going to happen in this numerator right now. I need to FOIL this. So I'm going to have square root of x plus 1 times square root of x plus 1. Basically, that's the square root of x plus 1 being squared. The square root and the squareds cancel out, and I would just be left with x plus 1. And that's much simpler. Okay, then as I complete the FOIL process in that top, the O of FOIL, I'm going to get 2 times square root of x plus 1. And the I of FOIL, I get that same idea, but it's going to be negative. So they cancel each other out. So just kind of think about that. If you did the O and the I of FOIL, can you see how they would cancel out in the numerator? And then the L part of FOIL is a -2 times a +2, which is -4. Okay, so that all seems to be pretty good. The denominator is pretty messy right now. So I am just going to rewrite that. We're not going to try to combine those things in general, just leave it alone. And +2, okay? But I want you to look at what happens to the numerator here. So again, we're going to write down the limit as x approaches 3 because we haven't actually evaluated the limit yet. But when I do that, the whole numerator just simplifies to x plus 3. And in the denominator, I still have, I'm sorry, it shouldn't be x plus 3. That should be an x minus 3. Sorry about that. Okay, and then in the denominator, I still have x minus 3 times the square root of x plus 1 plus 2. And the nice thing is these things kind of cancel out. If we have all these chunks now in a big fraction, if we see the same thing on the top and the bottom, they cancel out. So in the end, again, writing out the limit as x approaches 3, I would now have a 1 in the numerator and the square root of x plus 1 plus a 2 in the denominator. And now if we look at what happens when I plug a 3 in, because now I don't get that 0 over 0, now I get something good. So now I can stop writing down the limit idea at the very beginning, because I'm going to plug the 3 in, and I would have 1 over the square root of 3 plus 1, which is going to be 4. Still add the 2 at the end. Again, if we go through and we kind of look at that, square root of 4 is 2. 2 plus 2 is 4, so my answer here is 1/4. That is the limit. Now, if I went back to the graph that I had kind of provided in the previous slide here, the graph of this function, or if you graph this on your calculator, if we zoomed in right around x equals 3, we're going to see that the y values there are getting closer and closer to 1/4. So we're going to stop right there, jot down any questions you might have, and yeah, we'll talk in class.